We are live at the 5G Secretary Innovation and Technology stage. This is the time and this is the place where we'll focus on and give you more insights and knowledge on the technology shaping tomorrow's territory. This event is brought to you by the State Electronic Communications Office of Latvia, powered by the European Union funds, the Investment and Development Agency of Latvia, and Mission Latvia, in cooperation with the International Telecommunication Union, and together with the strategic partners, Ministry of Smart Administration and Regional Development of the Republic of Latvia, LMT, the Nordic Council of Ministers, and of course, the golden partner, the Digital Accelerator of Latvia. My name is Artis Ozoliņš. I will be together with you for these 2 amazing days on this stage right here. And this session is being recorded, which reminds me to welcome also all of the online viewers. Wherever you are around the world, we welcome you here at 5G Secretary. And we have a way to interact. First of all, the amazing audience here, thank you for being with us. We do have a live microphone if we will have time for questions. And for the online viewers, you know where you are. There's a comment section right underneath the live stream window where you can type in comments, and then we will see. It will be up to moderators on this stage if and when they will ask for questions. If that time comes, I will help translate your questions to the dear panel right here. But the authority that I have been given is to hold us in the time frame. And don't worry, I will jump on this stage like a SWAT team and interrupt if we go over time. That's actually my only task here today. But this first session is ready, and I have a question for you. Are you ready? Doesn't sound like it. Ladies and gentlemen, are you ready? Give me some energy. Yes, very good. So we are ready to start with our first discussion on the cutting edge of connectivity and mobility, taking us beyond the terrestrial networks we've come to rely on. Welcome to the future of satellite connectivity that will transform the way how we communicate, how we travel, and how we manage our transportation systems. From autonomous vehicles to smart transportation systems, communication will be essential. The benefits, the drawbacks, and everything in between will be moderated by our amazing moderator that has traveled to us from the United States of America. Ladies and gentlemen, he's the Vice President and Principal Analyst at Moore Insights and Strategy, returning to 5G Secretary for the 6th time. Ladies and gentlemen, Mr. Will Townsend.
All right. Thank you. Artis, thank you for that amazing introduction. Before we get started, though, I'd love for our panelists to do a quick introduction and provide an overview of what they do. So, Zois, let's start with you first.
Okay, I'm Zois Kokonis. I work for the European Space Agency. I come from a background in telecommunication and software of several years with vendors. And I'm really excited. This is my 3rd visit to the 5G territory, and I would say that in the first time, 2 years ago, space and satellite communication was practically not a topic that was discussed. It was coming up last year, and this year you will hear in many panels and many issues that we are discussing about the complementarity of satellite communications to terrestrial in order to serve areas, and transport and automotive mobility are an essential sector that we're discussing, so I'm really glad to be here with the colleagues to provide more insight into that.
Great. Well, Alexander.
Okay. Yeah, thank you for the invitation. Alexander Pabst, I'm the Vice President for the market segment wireless communications inside Rohde & Schwarz, which entails everything from cellular and non-cellular devices up to infrastructure. And thinking about this panel, we heard this morning Benjamin Vrake mentioning already Star Trek. I'm also one of the guys who watched Star Trek in my early days. And when I started at Rohde & Schwarz 27 years ago, I was actually hired because we had one satellite communication project, which dramatically failed. The satellites came down. But now, only 27 years later, we finally have a working system in place, and we have a good roadmap that my currently area of expertise which is on the surface of the Earth, is now extending into space, and that's a very exciting thing.
It is. You're a Star Trek fan. I'm a Star Wars fan, so I could talk for hours about Star Wars. But Raphael,
Yeah,
Welcome.
hello to everyone. I'm Raffaele Pepe. I'm board member and vice chair of the 6G Industry Association, which is the private part of a joint public-private partnership between the European Commission and the European industry. So what we do, we incubate 6G research, which is funded by the European Commission, basically, and we try as the private part to provide industrial guidance for 6G. I'm also a strategy officer in Telecom Italia Mobile, so I'm here also as representing the mobile operator world. I'm in the business since late 90s now, so I started with 2G. Now we are tackling 6G, so I accumulated a little bit of experience in the industry. And so I'm excited to discuss this integration with the satellite world, which looks very exciting, but let's see also to the economics, and we will discuss this a little bit later.
Yeah, it's going to be exciting. And Per, welcome.
Yeah, thank you for inviting me to this session. I'm Per Ljungberg, working at Ericsson, the CTO office, and I'm really trying to figure out how we can use all the networks, the 5G, in different applications. And now this session is about NTN and how to augment further the terrestrial network. And my previous work, we have been working with autonomous driving and mission-critical networks for different application areas, such as defense. And then, of course, it always pops up. What do we do with rural areas? What do we do with areas where we don't have a good 5G coverage? And then, of course, part of the solution is 5G compass networks and so on. But let's bring it forward.
Yeah, well, great. Well, I think it's important to first start with a level set on where things are at. You know, Zois, as you mentioned, this is a topic that's gaining a lot of momentum, a lot of discussion. So I'd like to start out with sort of the current landscape. And I follow AST Space Mobile in the United States. They're actually headquartered in West Texas. I am from Texas, and I've spent time with the Bell Avilion and AT&T as well to understand that partnership. But Alexander, maybe let's start with you. And what's sort of your perspective on where we're at? Because, for example, with AST Space Mobile, they've just launched their first 5 commercial satellites that, in fact, just opened their antenna arrays this week. Yeah. So where do you think we're at with this?
Yeah, I think it describes a little bit how this whole industry is in nascent right now. Looking back a little bit 2 or 3 years, there was obviously Apple coming out with the first feature of this emergency call.
SOS tech.
SOS capability, based on a proprietary implementation, proprietary satellite constellation. Qualcomm tried with Iridium. But then shortly after, also the standardization of 3GPP started with release 17, and they thought about reusing the narrowband signal for narrowband LTE, basically for the satellite link, because it has a very, very good dynamic range. It works on very low power levels, which is advantageous if you have geo satellites up at 36,000 kilometers. 2 years ago on the Mobile World Congress, we were able to show the first live demo of a device that was Bullet at the time. Mm-hmm. And since then, a lot of things happened. We have now basically all the chipset vendors that jumped on that train. It's Qualcomm, it's MediaTek, it's Unisoc, it's Sony Altair, basically everybody. Yeah. Qualcomm just put the narrowband functionality also not just in their IoT chipset, but also in the high-end chipset. Mm-hmm. So we can expect to see that functionality very soon on the high-end phones from the major brands. We have Starlink, again, shaking up the industry with their LTE Direct. Right. And I think they did a great marketing coup in serving the Florida flooded areas, getting that temporary license from the FCC. From the
FCC, yeah, both for Florida and also for the Carolinas that were devastated by those 2 hurricanes back to back.
Yeah. Right. So at the moment we have bidirectional communication on narrowband. We have this LTE Direct, which for me is just a stepping stone, because long term, I think, looking at the ecosystem in general, it needs to merge into 3GPP standard to be really used worldwide.
I agree. Yeah, that's the only way it's really going to scale. So I know. So Zois, you wanted to talk a little bit about Apple and Globalstar and that. Can you go into a little bit of depth, and what do you see with the potential in that partnership?
I think that was a very important move. Because what we see is that Apple is using some capabilities which are already there. So the Globalstar satellites did not fly for Apple. Apple just used existing infrastructure, and they provided a service in a proprietary manner, circumventing the networks. This is something which is not uncommon. They are providing a sort of an over-the-top service for emergency, for some very specific use case. They started with emergency, and the next, I think, roughly 2 years afterwards, they provided the service also for messaging. Now, it's the only service that was rolled out to use satellite directly from a phone, which was available. They offered the service. They did not make a demo or a test or something. They just said, you can use the service. What is interesting is it's not something that is charged for. So if we take the business perspective, they're not asking money for that.
Right.
So they say that we provide this as a bundle with our phone, with a set of other capabilities, so that we make business from our cell phones. So it is an interesting concept. You are providing, you're augmenting your connectivity capabilities in order to make business, but from the overall bundle. You are not seeking to sell this specific service.
Right.
And I think this is something which we should keep in mind when we try to understand how do we really deploy and monetize such capabilities. Another point that I would like to make is that we see that these capabilities, and Europe is not necessarily adequately part of it. We contribute technology from several European companies in that, but we don't necessarily see the European initiatives, which are having a prominent position in that, and this is an area where we should do something. So the European Commission is doing something in this direction with the Iris Square potentially, but we need more, and we need other capabilities in this direction. This is an area where ESA is focused and trying to help the European industry to position itself in this conglomerate.
You bring up a good point. There was no test phase and proof of concept. It was Apple announced it tied to an iPhone, a new iPhone, and from my perspective, it's Apple's attempt and opportunity to continue to create stickiness for people to continue to use their devices. And Apple has a very loyal following, but it was sort of groundbreaking. But that brings up a really good point and sort of a segue to sort of the second topic I want to discuss, and it's around use cases. And we've sort of talked about first responders, but maybe Per, we can start with you, because you and I were talking before the panel. You have some thoughts around applicability with narrowband, right?
Exactly. I mean, ubiquitous coverage in rural areas with narrowband IoT services from a satellite is, of course, a great thing. But then you need to understand, so to say, the limitations. I mean, you cannot do everything. And today in Europe, like here in Latvia, we have a good 5G network. It serves the area. You don't really need a satellite for having coverage to your vehicle to drive around. And there's a lot of, so to say, industry research, test, proof points, perhaps not launching it as a service yet, but more proof points to make sure that it's safe, it can be used. And in the industry forum 5G AA, there's a lot of discussion how to come to the higher ADAS levels or automated driving, etc. And I mean, some of that is very much about a very low latency, very high robustness, high reliability, and of course, resilience to cyber threats and things like that. And it's a whole thing. And what we more and more see is that satellite is, of course, a super good complementary technology. I think we'll talk about it here today. What can be done more? Yeah. But it's important to look at this from a holistic point of view.
And I think the first responder application is very compelling. We were just talking about how it was used with Starlink and T-Mobile in helping with some of the search and rescue efforts tied to the hurricane disasters that occurred. But also, Ericsson's a big part of AT&T FirstNet, right? Okay. So there's a lot of discussion about how does that get integrated into like a FirstNet network or other networks around the world that are established for the primary use of first responders, right?
And if you look at here in Europe, there's a lot of movement into replacing old Tetra networks with more modern 4G, 5G networks for public safety, police, ambulance, fire brigades, etc. it's coming, and I mean, part of that is using existing operators network, either directly or indirectly via MOCN solution with own core networks and so on. It's happening. It is coming. Quite many countries are on this move. It will, of course, take some years before it's fully implemented. And then, again, satellite is a super good complementary technology.
Yep.
No doubt.
Yeah.
So when that comes into the phones, absolutely.
It's not the single panacea, but it can certainly be an important element in bridging, especially the digital divide. I want to get into that in a minute. Raphael, any thoughts on what you feel are compelling use cases for non-terrestrial networks?
Well, I think that more exciting use cases are those coming from vertical, serving vertical industries. Basically, we have a bunch of vertical industry to serve with satellite connectivity, when it is integrated, of course, with mobile connectivity. Of course, as operators will provide you satellite connectivity when it is integrated within a sound business model of the operator. So this is a little bit the problem. Today, the IoT business, honestly speaking, is not really a very big business for the operator. Still, it's not a very big business. You know, an IoT line today in the world, at the worldwide level, is valued at €0.3 per line. So this is the value that has an IoT connection, a mobile IoT connection for operators. And this will go down to €0.2 per line in 5 years, so in 2028. So we will lose 50% of the value. Of course, an IoT line, the connectivity of a part of an IoT connection is just 10% of the value. So let's say our ARPU is 0.3, but totally the ARPU of an IoT line is, let's say, $3,
Sure.
€3. Sorry. So this is the business that we are talking about. So here the problem is basically, you know, the business model, the business that that operators have to grab from satellite connectivity. As said, according to my experience at least, operators will go for a standard solution.
Right.
So
and where the ARPU is, right? So,
yeah, it's where the ARPU is, exactly. So consider that to grab this €0.3 per month, operators have to invest in a new release, basically, because this will come with the release 17 of the 3GPP, where satellite connectivity is integrated in the mobile standard.
Right.
And to do that, operators have to upgrade their networks. So if you calculate, you know, the return on investment, it's not really there. But of course, the economic value is not the only value that you have from satellite connectivity. You know, the real value probably will come from the societal value, because of course, when you have a connected car which has an accident in the middle of nowhere, and thanks to satellite, you will have an ambulance getting there and saving a life. This has no value, of course. So the value is more than economic, you know, but the economic side is not the main driver for satellite connectivity for operators, you know, right?
I agree with that. IoT has been difficult to monetize in the past, certainly. But I do believe that we'll start to begin to see new use cases tied to agriculture technology. When you think about bringing connectivity to rural areas where a lot of farming and ranching occur, and being able to do things like monitor the health of livestock and to improve crop yields, use drones for surveying and for fertilizing and doing that efficiently and sustainably. And that could be a public-private, you know, sort of sponsorship. But I know, Alexander Rodenschwartz, you're very focused on test and measurement. You help build networks. What do you see as some very, you know, opportunistic use cases with NTN?
Yeah, I mean, for the narrowband, we discussed already the emergency use case.
Right.
You mentioned the cattle and the agriculture, and
the connected cow.
Yeah, the connected cow. Yeah, that's one of my colleagues' favorite topic actually. And I mean, looking here at Latvia or Germany, that's not a big topic. But if you look at Texas and the sizes of the ranches, that gets much more scale.
Right.
It's also things like pipelines that go through remote areas where you like to know if it leaks or if it has any health issues. This is not huge data. This is little data, but it's important to transport that data and to communicate that back home. The other thing that we saw, we had on Mobile World this year, we had a beautiful demo on the MTK booth who showed actually a KU band, so more a classical satellite band link with NTNR together with our test equipment. And the application was automotive, so they had a little tiny toy car and they had a antenna on top of it, a patch antenna, which was very innovative because it was just about this size, right? So 10 by 3 centimeters or something. And this created so much attention by the automotive industry because they saw a possibility to get uninterrupted coverage with high-speed data. Which currently is a real problem because they're talking about remote driving and so on, or fully automated driving. But fully automated driving means if something breaks, they have to have a fallback with an operator.
Sure.
So there is no fully autonomous driving. And for this fallback, they need to have uninterrupted coverage. If they cannot guarantee that, they will never be able to switch on fully autonomous driving.
Right.
So very, very high level of attractiveness on that side as well.
Yeah. While we were sort of discussing this, Zoyas, and we were, sort of planning the panel out, I know that you wanted to talk about sort of the differences between the European Union and the U.S. and, the geography expanses and the regulatory challenges.
So I think this is an important aspect that we need to understand that. We are discussing about, let's say, the evolution that SpaceX and Starlink had in the US. But we need also to check what kind of a market they were addressing. In the US, there are significant areas which have no cellular coverage. So you have a market from this perspective, plus the fact that you have people who are able to pay for this. On the other side, you have a very large area with a unified regulation. Now, if you would consider somebody trying to make the same thing in Europe, this company has to provide satellite coverage for an area which has very good LTE or even 5G coverage, plus the fact that the satellites are supposed to operate with different bands and so on. You have different frequency regulations for every country. And if you look at it from a satellite, then the borders are not so far away. So it's a much trickier area to provide a sound business model for that. Further example, if in the US, you have the partnership of T-Mobile with Starlink. Would T-Mobile do a similar partnership for Europe? Much more difficult, because they don't have such free areas of frequency that they can negotiate, that they use them from satellite. So it's a much more complicated environment, and Europe needs to understand how do we deal with that so that we can have the services that are needed, because as was rightly said by Raffaele, it's not just about the economic aspects, it's also about social aspects.
Right.
And even because I like to talk about the business, an important aspect of business is, can I offer my services in the same manner everywhere? So this is about this continuity. The service is not breaking. I can make the same offer to everybody. And that is an advantage for the businesses. So that's why they're looking for a communication infrastructure which covers and enables that. We cannot always look at defining the use cases up front, because the use cases appear as you have the capabilities. And I think this is a topic that we need to check in terms of this aspect.
No, I totally agree. It's interesting. I work pretty closely with Cisco, and Guy Dietrich runs their country digital acceleration program. And when he visits countries around the world, he's talking about smart city requirements, which require connectivity. One size does not fit all, Zois, to your point. And so you have to focus first with what is needed versus just putting the use case out there or putting the technology out there and hoping that they will come. That's usually a recipe for disaster in the tech industry. Before I became an analyst 8 or 9 years ago, I spent 30 years in corporate America, and as a product marketer, that's what we tended to do. It's just put technology out there, build it and they will come, right? This is different when it comes to connectivity and, and what's happening with satellite from my perspective. But I'd like to go back to a point that Raphael made around standardization. So early on, if we look back, a couple of years ago, companies like Qualcomm were sort of out in front of this, and they they eventually abandoned what they were doing because they weren't getting the scale that they needed because there wasn't a standard. Now with 3GPP, we're having standardization come into play with respect to the interoperability between non-terrestrial networks and terrestrial networks. So, Alexander, I'd love to start with you. Let's go a little bit deeper here, and how will a standardization really drive scale?
Well, as you said, standardization drive the scale, of course, since it will come, satellite will come natively in our smartphones in a couple of years. So the capability will be there, and use cases will come somehow. No? Mm-hmm. So I think this is really what will make the difference. That at a certain point, that the satellite will be natively integrated into mobile communication, and up to us to find, the best use cases and how to monetize them. So this is really important. If you think that now after 5G, 6G will arrive in 2030, and 6G will be the first real mobile standard with satellite inside. And you say, okay, but what will be 6G? What is 6G? Well, how can this help with satellite communication? 6G is basically an evolution of 5G with some new interesting features. Now, first of all, we will see artificial intelligence natively embedded in the networks. Mm-hmm. So that AI will...
NVIDIA is certainly trying to drive that with their 6G RAN, right? Yep.
Yeah, exactly.
Yep.
This will come in RAN natively, exactly, in a 6G. But 6G will have also a new concept of integrating sensing and communication. So for the first time, the network will not be only a communication network, but also a sensing network, which is kind of change of paradigm in a mobile world. So the communication network will sense the environment, will be able to do better weathercast forecasts, will be to sense the traffic. I did a trial. They sense my heartbeat just with this base station from remote. So here we have a bunch of new opportunities will open with 6G, and the satellite will be inside this. So I think that, and we'll add scale to the standardization. So I think there will be nice things to see.
Sure. Alexander, what do you think?
Yeah, standardization for me is really key to success. We saw that, and we both have at least some gray hair.
I have no hair.
When GSM came into play before, as you mentioned with CDMA, we had some isolated solutions, but right. From the time where we had a global communications standard, where you could use your same cell phone everywhere on the world, where you could finally, without telling the phone where you are, do a call. This is what really made the breakthrough, and that's the success for GSM up to 5G right now. Now integrating satellite in that will require the satellite networks that are, again, yet another island so far, or have been yet another island, right. To connect this island with a lot of bridges into the 5G or 6G infrastructure, which is currently happening by people like Skylo. They are building such a connector, but at the moment it's a connector. With 6G, it will be a native wire that's already there, and it will be part of that. So. Yeah, and a lot of things we didn't discuss about the different constellations, but you mentioned Starlink and AST. They are working this low Earth orbit. We have Skylo. They work on geostationary satellites. That's not efficient. You either stay on the terrestrial or you stay on the G, where you're just parked there. And if you need capacity, you go down to a low Earth orbit where you can draw more data. So there's a lot of standardization required. We're heavily working on that, and that will be the key to make this really an acceptable standard to the users.
Per, I mean, Ericsson's certainly very involved in driving standards. When you look at RAN infrastructure, core infrastructure, you're a leader, in those areas, transport as well. What are your thoughts about how this can drive scale and ubiquity?
I concur with the other panelists that standardization is a key ingredient to have a scale both on the infrastructure part and on the device part. And that together will then make other vendors possible to build applications that can share information and make use of the network connectivity as such. And as you said, I mean, if you have different satellites, there's a lot of technicalities in this. Should we connect to one or two and so on? And I mean, and different networks and how to use them in an efficient way. And of course, over the years, terrestrial network is there. It can be used. Then you can augment with other capabilities, but it's super important to be clear on the capabilities. I mean, you cannot have both ultra-low latency and coverage in tunnels, underground, in parking houses, etc. With the satellite. It doesn't work.
Right.
So just be clear on what you can address.
Right.
But if you're clear, perfect. I mean, if you're out in the rural area, you want to receive some information, my car has crashed or something, I mean, or you just want to get a notification there are moose on the road ahead, I mean,
yeah.
Good to know. But if you want to do remote teleoperated driving, having low latency, perhaps not.
Right.
And safety, accreditation, so standardization, first, foundation, companies, standardization, or product accreditation and certification to make sure that it can be used. And then, of course, the ecosystem kicks in that there are SMEs and big companies doing clever things.
Yeah, I mean, again, non-terrestrial networks aren't going to solve all the issues, to your point. It does require an ecosystem approach to make it all work, right? It's not, you know, it doesn't fall on one particular, you know, company or consortium. But Zois, I'd love it if you would go a little deeper into like spectrum usage, because you and I were talking about this earlier. That's a challenge, right? When you look at, you know, satellite, you know, operational spectrum and cellular spectrum and harmonizing that and making that all work, right?
Yes, and I will grab maybe a little bit this historical approach that we're taking. If you consider the early generations of cellular network, you were focusing on one frequency. There was one specific frequency band that was used, and it was even incompatible between countries. So if you would go with a European phone in the US, it wasn't working. And the hardware was not working. Yeah. Now we have a situation where more and more bands are integrated into the 3GPP standards and now following the standards, and you have also the interoperability with the frequency bands that are not licensed. The concept of using unlicensed frequencies for calls and so on, it is also something that was developed, that you have voice over Wi-Fi with quality and video over Wi-Fi with quality. So these are aspects that are evolving. We are seeing an area where the network capabilities are growing to serve more and more needs, and the needs are getting more and more as the network capabilities are there. You cannot expect that you have evolution only in the network or only in the communication part. You have evolution also in the other aspects. And I will, if you allow me, I will take an example.
Yeah.
Which one of you is using video calls on their mobile phone? Raise your hands. Okay. I would say almost everybody. Now, a bit more than 10 years ago, that was the 3G area, I was responsible for a service, for a video service for 3G. And it wasn't selling good. And what people were saying is, well, people are not comfortable to have video calls on the mobile because it could be intrusive in what they are doing. It could be, no. The 3G video quality was lousy.
Right.
The phones did not have the right cameras.
Yeah.
You had camera only on one side of your phone, so you couldn't, so the technology was not there, but it was not just the network. It was the phone, the camera on the phone, everything was like that, and the people were not using that. So you need to have use cases evolving together with the technology. That is why we need to integrate and involve the users for the aspects of the technology and the connectivity all through this cycle to innovate together, to check what is currently possible with narrow bandwidth services. We can do something. The bandwidth will be increasing, the latency will be lowering, and we get more and more situations, and we find the right application in the right situation where we use terrestrial and where satellite will complement. It's not either or, it's the combination. And the approach in 3GPP to integrate the satellite standards and to take care of non-terrestrial networks is an excellent move, and it just started with release 17. So We are on the beginning of this era.
You make an excellent point. The tech stack has to be there as well, right? And not only does the technology have to be present, but it has to be affordable, it has to be pervasive in the market. And I believe what's exciting and what's really been driving the momentum recently around NTN is the whole notion of being able to take an unmodified smartphone and use what Starlink and AST Space Mobile and OneWeb and Project Kuiper with Amazon are trying to do, which is provide connectivity without having to modify that smartphone. You don't have to put a geosynchronous chip or a low Earth orbit satellite chip in a phone that adds cost that people might not want to pay a premium for. You're using an unmodified device, right? So that's a good example of all of a sudden, these devices that we carry in our pockets that have the equivalent of a supercomputing power of the 30, 40 years ago is readily available, right? But that's a great segue for our final topic as we wind down the panel, and it's monetization. Because from my perspective, I've been pretty critical of a lot of MNOs that have really focused, within 3G and LTE and to a lesser extent with 5G on access. And then the over-the-tops, the Metas of the world take advantage of those billions of dollars and billions of euros of invested infrastructure. So, and Zois, you touched on this very briefly with the Apple example. That's an example of where that's not necessarily going to be incrementally monetized. It's bundled with the Apple phone. It's Apple's way of providing an additional premium service to keep its customers, maybe take Android customers into the iPhone. But what do you think are some other viable monetization opportunities for the people that are actually investing in all this?
That is a very good question. And I believe that we should always see connectivity as an enabler for something. Nobody is just interested for the connectivity. They're interested for something that they are able to do with connectivity.
Right.
So taking Rafael's approach that IoT, what we are gaining from each connection, the revenue from each connection is very low. Yes. The idea should be that the number of connections should go skyrocketing up. That is the only way forward. But this means that there is a digital transformation progressing which will do something with all these connections. So it is not an easy answer.
No.
And practically, if you take the satellite aspect, inside, what do you have? You have satellite operators which say, okay, we need to provide connectivity, so how will we be monetizing that? We are providing a complement to the mobile operators. What do the mobile operators get? You have a situation where you have virtual mobile operators, which do not have an infrastructure, but buy connectivity service and resell it. So what you are seeing in such a digital environment is you are dissecting the value chain, and every company needs to find out, okay, how do I position myself correctly in this area so that I monetize? You see that mobile network operators are now providing cloud services. Vendors, telecom vendors like Ericsson and Nokia are providing cloud infrastructure capabilities for that. So they are shifting what they are selling based on how the market develops. You have a digital transformation, and in my view, what is essential is that this digital transformation allows to have smaller and smaller segments of this value chain which can be exploited. Mm-hmm. So I'm not sure I gave you an answer, but yeah. I elaborated on the question.
You did, and you did a great job elaborating on that. Alexander, you work very closely with mobile network operators and CSPs. I mean, are you hearing any whispers from them on where they think they can monetize NTN?
I hear whispers from both sides. I mean, there's the obvious one is obviously adding the satellite link as an extension to the existing pipe. Yeah, right. And with that, probably you're not able to generate a lot of revenue. Honestly thinking, I mean, for everybody who has ever been in a coverage gap, it's attractive, and I would probably, personally, I would pay maybe €2 more every month to make sure I have continuous coverage. Same for my family, because it keeps wife happy anyway. But I think we also need to think a little bit beyond that in terms of there are lots of activities right now to bring compute capability to the edge. Yeah. Obviously, if you do that, it doesn't help if your smartphone has AI only on the smartphone. You need to connect to the edge. Connecting to the edge means you need to have continuous connection to the edge because they are putting compute power there to generate data traffic, and this data traffic needs to flow somewhere. The other thing that we're seeing at the moment is a huge push also by the satellite operators that so far have been on their island. They now like to move to the continent and conquer also the terrestrial users.
Right.
So there's a big competition also coming up right now between the incumbent satellite operators, the incumbent terrestrial operators to fight for the users. And we have to see what kind of additional services will come up out of that. I think also healthy competition.
I like your point on edge AI. When you look at what's happening with generative AI, today it's large language models that are connecting to the cloud, but we're beginning to see a hybrid hybrid model where you're seeing the introduction of AI PCs. You're seeing the introduction. I was with Qualcomm at their Snapdragon Summit last week in Maui. Beautiful, beautiful place for an event. So is Riga. But they talked about their Snapdragon Elite 8 and what they're doing with integrating an NPU, a GPU, and a CPU to do on-device AI, which can do a lot of things like from security to actually supporting generative AI applications at the edge of the network where data is being created. And it's going to unlock a whole host of use cases. It's going to reduce the power consumption that many people are concerned about with NVIDIA GPUs and data centers and cloud infrastructure and that sort of thing. So I'm glad you brought that point up because it gave me an opportunity to talk about that. But Per, what are your thoughts here?
I think the monetization comes in two steps. I mean, we talked about the mobile phones that drives the mass market, obviously. That's one type. And then you have the more industrial business case, the industrial Internet of Things. I mean, it's a completely different thing if you build a modem that is supposed to sit in a vehicle. It's a completely different story. And then the services that goes together is also different. I mean, if you are in the public safety segment, you want to have a ubiquitous service that really works in your country. You come in all this sovereignty and things that we talked about in the first session here in the morning. Should we trust US satellites?
Well, we have sovereign clouds now, right? And we have that concern. You certainly in Europe, you're a leader in protecting privacy and with GDPR and that sort of thing. It's not an unreasonable assumption, or concern, right? To have that.
And it's also because of this that when you move into this more mission-critical space, it's more like you can also pay a premium for having the service in a certain areas, rural areas, or during specific events or whatever, because then there is the need to have it. I mean, the operators are putting out extra equipment when there is a soccer game or something, or a festival or something.
Right.
Yep, there is people. Let's pull in more gears.
Right.
Because there is an obvious business case, even if it's only to have your photos on Instagram.
Yeah.
But it's a business case. And similarly, if you have something that goes into the police, fire brigade, rural areas. We had a terrible forest fire some years back in Sweden, and then the people from other countries, Poland, came with 30 trucks. They come with their equipment to Sweden, helped us. Unfortunately, they were not interoperable.
Oh, wow.
So instead, they took up their mobile phones, and of course that worked because give me your phone number, and we can send some discussion.
Right.
But so it's part of this process of making the ecosystem working.
And and that's been a challenge in the U.S. for many years. Our first responders were on a proprietary Motorola system that dated back to the 1950s, right? And so that's why FirstNet was created, was to bring that that uniformity to harmonize those communications. But Raphael, as we wrap up the session, what are your thoughts about network programmability? We're hearing from Ericsson, their joint venture with a lot of mobile network operators on driving, exposing APIs so that developers can more easily develop all kinds of applications. Nokia has its network as code. Do you see that as an opportunity here in conjunction with NTN?
Yes, absolutely. I think this is one of the hot topics in the industry in this moment. As you know, GSMA launched this Open Gateway initiative in which most important operators in the world are sitting and are exposing their network APIs in a federated ways. So this is really a safe business environment for the operators, a place where they like to stay because they can monetize their fundamental network assets. Honestly speaking, I saw the numbers and they were not really encouraging, but still it is the place where an operator can add value because take, for instance, the connected car example now. In these last days, we had some agreements between car industry and telecommunication industry to create slices and network APIs for the automotive industries. This means that if you buy a network API within the Open Gateway initiative, you buy it here in Riga to the local operator, it automatically works all around the world because it is federated with 64 other big operators worldwide that will become more and more. So this is really triggering, the value because Tesla will do an agreement with AT&T in US and it will work worldwide. No, the Tesla car will be connected to network APIs with all the other operators around the world, as is today with the smartphone. Today, you do a local contract with your mobile operator, but it works in roaming everywhere else. And that is really exactly the business model that we need, that could work. Also, the numbers are, we cannot expect, to have the same business as usual connectivity, but still that works. That is a way to do business for operators, and that is a safe environment, and I strongly believe in that.
Well, it's been a long tail. I mean, this is something, we were talking, I think, Zois, last night. I mean, this is a concept that's been kicked around for probably 2 decades, right? And I think, and Alexander, we were the three of us were talking about this. And I think, some of the concerns were, okay, number one, it's something that's new. So that is somewhat intimidating, maybe to the MNOs. Number two, is it going to break the network? Because, you're focused on resilience and capacity and not wanting to churn subscribers. And if you have a network outage, that's terrible, right? But I think now with GSMA getting involved with Open Gateway, it's providing the confidence level. And we're beginning to see a lot of very compelling proof of concepts that are really beginning to expose the value of network programmability. So, I mean, with that, Alexander, Zois, would you want to add anything to that before we close the panel?
No, I think that was pretty well laid out.
Okay, awesome.
I think Raffaele captured that very nice. This approach towards APIs was something that was introduced actually with the 5G, the previous releases as a concept. It was advocated and considered, but that is something which also touches in the standardization. You need adequate, let's say, commonality in achieving that.
Right.
In the IT world, the big cloud companies like Google or Facebook and so on, they are creating the APIs, but they have the volume to achieve that. If you're going to the telcos, you have a much more fragmented area. So the approach is that they have this commonality in APIs, and the SATCOM operator should join exactly this aspect. And this is something that they're doing, and ESA is also sponsoring such activities, that we have this so that you can have this digital transformation in how you are consuming the network capabilities, so that you can match it. But you need the volume, and the volume is coming through collaboration in such cases.
Great. Well, it's been a great conversation. We actually have time for Q&A, which is amazing. I thought we would talk for another 2 hours. So, artists, do we have any questions from online? Or
we have so many questions that I will ask our dear participants to maybe later on log on and answer some of them, because we don't have time for everything. But first of all, the audience, you spent your time, you came here, we have a question right there, maybe someone there, and then we'll see how it goes. Hello.
Thanks. Hi. Dean Bubley from Disruptive Analysis and the 6G Reset Initiative. Very interested in the idea of linking NTN with terrestrial mobile for coverage on roads and so on. But are the satellite networks going to be essentially wholesale or open access or neutral host providers, or does each terrestrial MNO need its own partnership? So Vodafone goes with SpaceX and T-Mobile goes with AST or whatever the combination is. Or is there going to be the European model where you have one satellite LEO constellation, but all of the operators can roam or peer or interconnect with it? Is it inherently shared resource?
Yeah, great question, Dean. Who wants to take that?
Could I elaborate on that? I think that the question is quite, so it is a free market, so everybody can choose what they're doing, and the question is how do you provide the right opportunities, and how does the public funding support the creation of such opportunities? So it's not an either-or question. Some companies will go one way, and maybe they even change what they're doing in the future. So,
and we see already today it's not even a one-on-one connection. Like the US operators, they work with AST Space Mobile, they work with AST, and they also work with Starlink, and they work with Skylo. So it's like roaming. They also work with the German operators, work with multiple Italian operators.
We have a question there. Hello.
Yep.
Yeah, thank you very much for the interesting discussion. Mina Boubendir, Airbus Defence and Space. So you touched on the direct-to-device and the need for standardization. Maybe the Ryzen Association, the MSSA, the Mobile Satellite Service Association, that wants to target the direct-to-device and the use of the 100 mega available from the terrestrial on ready devices. But maybe the question is more to terrestrial and chipset and device makers. How ready, what's the perspective in terms of devices to reach the direct-to-device? So we know the industry, the satellite industry is targeting this. We're working with the terrestrial towards this, but the biggest vendor and telcos are also relying on the chipset makers and device makers. What's your perspectives on this thing?
Who wants to take that one?
I can maybe jump in. So as I said in the beginning, we have Starlink with LTE direct-to-device, which has some drawbacks in the satellites. They need to do a lot of effort to enable that. Right. So I personally think this is not something that scales, and that's why I think at some point of time they will move into NTNR 3GPP standard to also get the throughput and to get the scale and to get the complexity transferred to the device. Because
there are concerns in the US by other operators that it's going to create interference with the way that they're implementing it, right?
That's another one. I mean, that's the case also that Zoe said this will never ever work in such a small scale country or area like Europe. Right. Imagine Luxembourg. You will never have a beam that just covers Luxembourg or Switzerland, even though Switzerland would have an advantage of getting coverage extension, right? They will not be, the beam doesn't stop at the border, and then you have interference in Germany, in Austria, in Italy, wherever. Yeah, that doesn't work. So it needs to be a bit more standardized. And by the way, there's also interference coming from the terrestrial base stations going into the satellites. They just blind them if they, so there's some standardization activity. So yeah, and looking at Ku-band, I think 2 or 3 weeks ago, Korea, KSAT, they made the first live demo of doing an NTNR connection over a satellite with our instruments, which was quite nice, really breakthrough to see that also NR actually works over a satellite today. Existing satellite, existing infrastructure, basically band pipe approach, but using NTN, NR over a real satellite.
All right. I guess we are at time, aren't we?
We are. Excellent. I think our dear participants deserve your applause.